Hey guys, Mr. B here. In this video, we're going to be going over the chapter 10.3 practice problems. Alright, here we go. Starting with number 1. So it says, in your own words, define the term radioactive decay. Alright, so remember that radioactive decay is when we have an unstable element that is breaking down into a different element over a set period of time. So we're going to say something along those lines. So we'll say radioactive decay. Radioactive decay is when an unstable element breaks down into a new element over time and gives off energy or radiation. All right, something along those lines. All right, number 2. How does the composition of a rock containing a radioactive element change over time? Well, we basically just answered this in the previous one here, but the composition of a rock containing a radioactive element over time will turn from one element into a different element, right? Because that radioactive element is going to break down and turn into a new one. So to answer this one, we can say the composition of a rock containing a radioactive element will change over time into a new element, and the rock's composition will change because of that. Something along those lines. All right, number 3. See if we have enough space here to answer this one. It says, how is a radioactive element's rate of decay like the ticking of a clock? Explain. All right, so remember that when elements that are radioactive break down, they do so at a set rate, right? Just like a clock is constantly ticking at a set rate as well. So we're going to say something along those lines. So we can say that the rate of decay is like the ticking of a clock because it happens at a constant rate, just like a clock ticks at a constant rate. All right, and let's see if we can move that in. It's not exactly what I want to do, but that's fine. As long as we can, I just wanted to be able to read this, and it's just not over the little Pearson logo. All right, moving on. Question number 4. What method do geologists use to determine the absolute age of a rock? So the methods that they use is radioactive decay and half-life. Okay, so geologists use radioactive decay and half-life to determine the absolute age of a rock. All right. Number 5, why is it difficult to determine the absolute age of a sedimentary rock? All right, so remember that sedimentary rocks are made out of a bunch of smaller little rocks that are like all kind of jammed together, okay? And each of those smaller little rocks could be made of all kinds of stuff, and they're each going to have their own individual absolute age. So if you try to find the age of a sedimentary rock, since it's made of all these smaller rocks, you're going to get numbers that are all over the place. Okay, so this is why it's difficult to determine the absolute age of a sedimentary rock. So we're going to say something along those lines. So we'll say that sedimentary rocks are made of a bunch of smaller rocks that each have their own absolute age. Because of this, if you try to find the absolute age of a sedimentary rock, you will get numbers that range or that vary a lot. Something like that. So, all right, number 6. A geologist finds a fossil in a layer of sedimentary rock that lies in between 2 igneous extrusions. How could the geologist determine the age of the fossil? All right, so if we have a sedimentary rock layer with a fossil in it, and it's in between 2 igneous extrusions, then what we would need to do is we would need to radioactively or radiometrically date the igneous rock layers to get an absolute age for those, and then we know that the sedimentary rock layer or the fossil in between them is somewhere in between that time range. Okay, so we're going to say something along those lines. So we can say the geologist could use radiometric or radioactive dating on the igneous rock layers, and then the sedimentary rock layer would have an absolute age that is in between those two rock layers. Something along those lines. Alright, let's, like I said, let's just... Oh, alright, we're just going to do that. Just going to, again, I want to just make sure we can read this so it's not over the little Pearson logo. Alright, last question here, number 7. What % of a radioactive element will remain after 7 half-lives? Alright, so this is a little bit of a math question. But remember that every time one half-life occurs, we are losing 50% of the material. Okay? So at 0 half-lives, we would have 100%. At 1 half-life, we have 50% left, right? Half of it's gone. So at 2 half-lives, we have 25%. At 3 half-lives, we have 12.5%. Okay, I might need to get a calculator here to do this math. At 4 half-lives, all right, so I'm going to start doing this on my calculator. So let's take 12.5, divide that by 2. So we have 6.25%. At 5 half-lives, so we'll take 6.25, divide that by 2. 3.125%. At 6 half-lives, we'll divide that one in 2. And we'll just keep it at 3 decimals, I guess. 1.563%. And finally, at 7 half-lives, we'll take that, divide that in 2. Again, we're going to have 0.781%. Okay? So what percent of a radioactive element will remain after 7 half-lives? About 0.781%. All we're doing is, again, we're taking 100, divide that by 2, take 50, divide that by 2, we'll just divide by 2, divide by 2, divide by 2, divide by 2, until eventually we get to 7 half-lives. And that's it. Alright guys, so that is it for this section of notes and those questions. Hopefully that helped you. And as always, if you need any more help, feel free to reach out. Alright, I'll see you in the next video.